Multiplication and Division of Fractions, Lesson 2. 7.3b Computations and Algebraic Relationships. Apply and extend previous understandings of operations to solve problems using addition, subtraction, multiplication, and division of rational numbers, specifically fractions. This is a readiness standard and in reporting category 2. Today is great just like you. Welcome to class. To be successful today, we will need a computer, our notebooks, pencils, pens, colored pencils, and markers. And today we're going to complete the Do Now, learn and practice how to multiply and divide fractions, and complete the exit ticket. Thank you for being you. I would like for you to hit pause on this section, and I want you to answer who is right and why the others are wrong. Marvielle needs to sew 2 pieces of fabric together. One of the pieces is 4 1/2 inches and the other is 7 5/8 inches. What will be the length of the piece that Marvielle is sewing together? Jonah says the answer is 12 1/8 inch. Marcus says 3 1/8 inch. Brenda says 97/8 of an inch. And Aiden says 11 6/8 of an inch. Who is correct? I look forward to hearing your responses and message me if you would like to share your understanding with me. Multiplication of fractions. How do I multiply fractions? Well, there are 3 steps to multiplying fractions. Step number 1 is to multiply the numerators. Step number 2 is to multiply the denominators. And then step number 3 is always to simplify the answer to the lowest term. So remember, to reduce to the simplest form, we divide the numerator and the denominator by the same greatest common factor, or GCF, to form an equivalent fraction. It does not matter if the denominators are alike or unalike. Multiplication goes straight across for fractions. That means the numerator times the numerator over the denominator times the denominator. So let's practice that. I like to show this with arrows because arrows can indicate multiplication. 1 times 2 is 2. 3 times 3 is 9. And that is the most simplest form for that fraction. Next, we have 4 times 7 and 6 times 8. That gives us 28 over 48. Now, in order to simplify that, we can divide both of those by 4, which gives us a value, the numerator and denominator by 4, of 7/12. So remember, always, always, always simplify. Now, just as a reminder, converting a mixed number to an improper fraction, we do what we consider the Texas turnstile. So if we have 1 2/3, the first step is to multiply the denominator and the whole number, 3 times 1, which is 3. The second step is to add the numerator to the result. So our numerator was 2, we add 3 plus 2 to give us a total of 5. We use this number as the numerator and use the original denominator as the denominator. So for an improper fraction, this would be 5 over 3, or 5/3. Multiplying mixed fractions. There are 4 steps to multiplying mixed fractions. The first is to convert the mixed number to improper fractions. The second step is to multiply the numerators. The third step is to multiply the denominators. Step number 4, always remember to simplify or reduce the answer to the simplest, lowest form. So here we have 2 1/3, which we can write as an improper fraction, 7/3. Then we have 1 1/5 that we can write as the improper fraction, 6/5. So in order to multiply these mixed fractions, step number 2 would be to multiply the numerators. 6 times 7, straight across. And there we get an answer of 42. The third step is to multiply the denominators. 3 times 5, which is 15. This gives us an answer of 42 over 15, and we can divide by 3 to get 14 over 5. The GCF that we would like to use here would be 3. Now, if we simplify that down further to a mixed fraction, we'll get 2 4/5. So let's practice that. The first thing we want to do is to convert these fractions to improper fractions. So 7 1/3 means we would multiply the 3 times the 7, and then we would add 1 to that. So 3 times 7 plus 1 would go in our numerator position. The 3 that we originally had as the denominator would stay in the denominator position. So 3 times 7 is 21, plus 1 is 22. 22 over 3 is our first fraction, written in improper form. The second, 4 times 3 plus 2. 4 times 3 plus 2 is written in our numerator position, and our same denominator we keep, 3 in our denominator position. 4 times 3 is 12, plus 2 is 14. So here we are multiplying 22 over 3 times 14 over 3. When we multiply those two together, we get 308 over 9. 22 times 4 is 308. 3 times 3 is 9. When we simplify that down, we get 34 wholes and 2/9 remaining. Always remember to simplify. Let's try that again for the next problem. 2 times 5 plus 4, which is 5 times 2 plus 4. That goes in our numerator position. We keep that 5 in our denominator position. 5 times 2 is 10, plus 4 is 14. Then we do that for our second problem. 5 times 2 plus 2. That gives us 5 times 2 plus 2, and that answer goes into the numerator position. We keep that 5 in the denominator position. 5 times 2 is 10, plus 2 is 12. So here for this problem, we have 14 over 5 plus 12 over 5. Because our denominators are the same, we just add those numerators together. 14, oh, nope, this is a multiplication problem. 14 times 12 is 168. So that's 14 times 12, multiplying our numerators. Then we have 5 times 5, which is 25. 5 times 5 is 25. If we wanted to simplify that information, and I'm going to squeeze it down here, that answer would be 6 and 18 over 25. Always remember to simplify. If you need additional support in this lesson, please make sure that you reach out to me and I can help you with that. Let's look at division of fractions. Dividing is cool. Do you want to see a video about it? You can check out that video here just to make sure you get a little bit of extra support. Now, do you remember keep, change, flip? That's where we keep the first fraction exactly the same. We change the division symbol to a multiplication symbol, and then we flip that second fraction to the reciprocal. So to begin with, we had 4 over 5, and when we flipped it, we have 5 over 4. That is called the reciprocal. So if we were to practice, we would begin by writing in our keep, change, flip. So we keep that first fraction exactly the same. We change that division to a multiplication, and then we flip that second fraction. If we keep that first one the same, it is still 3/4. When we change that division, we change it to a multiplication. And here now, instead of 2/3, we flip it to 3/2. That is flipping to the reciprocal. Because we are now multiplying, we just multiply straight across. And that gives us a value of 3 times 3, which is 9, over 4 times 2, which is 8. And we can simplify that to 1 1/8. Let's check for understanding to make sure that you got this. Very simply, we start with our keep, change, flip. So here we keep, change, flip. We keep the 2/9 the same. We change that division symbol to a multiplication symbol, and you are welcome to use whatever multiplication symbol you like. And then we flip that second fraction from 1/3 to 3/1. From there, this is a multiplication problem, so we can multiply straight across. 2 times 3 is 6. 9 times 1 is 9, and we can simplify that down to 2/3. If you need additional support with simplification, please remember to reach out to me. Here we have another division problem of fractions, but one of them does not look like a fraction. No worries, we can fix that. So we start with keep, change, flip. Now this first one, we're going to keep it, but we're going to keep it as a fraction. How do we change a whole number to a fraction? We put it over 1. Then we change that division symbol to a multiplication symbol, and we flip that second fraction to its reciprocal. So here we have 2/3. We flip that to 3/2. Now that we have a multiplication problem, we multiply straight across. 5 times 3 is 15. 1 times 2 is 2. And we can simplify that down to 7 1/2. Great job. Let's jump into this wrap up. Jimmy has 120 caramel apples to sell. Each caramel apple is covered with one topping. So 1/5 of the caramel apples are covered with peanuts. Let's see if we can solve this information here. So for caramel apples, we have 120 over 1 because we want to write that as a fraction, and that is being multiplied by 1/5. Okay, when we multiply that one, we know that multiplication just goes straight across. 120 times 1 and 1 times 5 gives us 120 over 4, which simplifies down to 24 of the caramel apples being also covered with peanuts. We can do that problem again to solve for chocolate chips. So how do we do that one? 120 over 1 times 1/3. We know that multiplication of fractions goes straight across, so that gives us a value of 120 over 3, which simplifies down to 40 caramel apples covered with chocolate chips. Next, we have 3/10 of the caramel apples covered with coconuts. So that means we have 120 over 1 times 3/10. Multiplication of fractions goes straight across, and that gives us a value of 360 over 10. That simplifies down to 36 caramel apples that are covered with coconut. It says the rest are covered with sprinkles. Well, let's just do a simple subtraction to figure out how many caramel apples that are left over that are covered with sprinkles. So we have 120 caramel apples to begin with, minus 24 apples that are covered with peanuts. That leaves us with 96. Then we subtract the 40 apples that are covered with chocolate chips. That leaves us with 56 apples remaining. And then we subtract the 36 apples that are covered with coconuts. That leaves us with 20 apples remaining. Because the rest are covered with sprinkles, that means that 20 apples are covered with sprinkles. Very good. Let's look at the discussion question activity. Why does keep, change, flip work? Changing from dividing fractions to multiplying fractions is why we use keep, change, flip. We use it, IP, to find the reciprocal in that flip portion. Why do we use that? That is the question. Why does keep, change, flip work? So if you would like to participate in this activity, please click into the Google form. And if you want a response from me, please ensure that you add your name to the last page. Great job on today's activities, ladies and gentlemen. Happy learning. Message me with any questions, comments, or concerns. Happy learning.